Hello everybody and welcome back to the channel. This is Jeremy. I had a customer job come in recently and I want to do a quick video on this. So a customer had brought me these cylinders and pistons from an R100 BMW Airhead motorcycle, similar to the one that I have, my R80/7, which you've seen on this channel. And anyhow, the customer needed the cylinders to be inspected. They had taken this apart. They had done a light hone job at home, I'm assuming probably with a hand drill and a ball hone. And they just wanted to get some measurements done because they couldn't get the ring gaps correct. And we found out that it does exceed the BMW specifications, and the customer has a couple of different options of things they might want to try depending on what their goal is for their project. But anyhow, I want to show you the correct way to measure a cylinder. Now there are many people on the internet that measure cylinders, and they're really in a home shop. They're trying to get by. Maybe they're hobbyists and they're just trying to get by in their garage or whatever. But there is a proper way, especially on a higher end machine like these BMW Airheads. They don't give you a lot of tolerance. You got to make sure that your measuring tools are accurate. And so we're going to take a look at a few of those, and then I'm going to show you measuring this on this video. Hope you enjoy this today. So here on my granite table, I have laid out a few different types of measuring tools, and we're going to talk about each one very briefly, and then we're going to go right ahead and show you the measurements on the cylinder. So the first one I want to look at is this telescoping gauge, because most guys, maybe our backyard mechanic or even a professional automotive mechanic, is probably going to have a set of telescoping gauges. Now this is a set of Starrett telescoping gauges, which is a higher quality tool. And basically, some people call them snap gauges or telescoping gauges. Well, I'll demonstrate this in a moment, but you can place it in the bore, and it's dependent a lot on your own feel and then the accuracy of your micrometer, but you can take measurements with the telescoping gauge. That was very popular even 50, 60 years ago in a lot of shops. Probably any home hobbyists that may be watching this video, this is just a cheap auto parts store brand digital caliper, and I did a review on this recently on my channel. Somebody may attempt at home just to use a digital caliper and to get a bore size on with their caliper. That's really not going to be accurate enough at all, and plus it limits you to the outer extremes of the cylinder. You can't get down in there to check for taper or any of other problems. And finally, I want to look at another older measuring device. This was a form of a dial bore gauge. This is the Starrett cylinder gauge. Now, this is a very high quality tool, and I do use this in my shop from time to time. However, it's only graduated in thousandths of an inch. You can see here it's graduated in 0.001, which is not going to be accurate enough really for what we want to do today. So you have the homeowner may have a telescoping gauge. They probably have a digital caliper kicking around. They may even have an older form of a dial bore gauge. But what I want to show you today is to really do this right. You need a dial bore gauge that is graduated to the 4th decimal place here, 0.0001. And what that allows you to do is to check what we would call in the machine shop by tenths. You see the difference from that 0 line there to the 1, that's only 1/1000th of an inch. You have graduated lines in there that split that thousandths up 10 more times, or to the 4th decimal place. And this is where you're going to be able to see any real changes within the cylinder as we measure it. So before we really get going, let's take a look at a telescoping gauge and how it works. What you do is clean your ends. These come in ranges. Typical would be a set of 6 telescoping gauges. And they go to different sizes, which you can pick which one fits to your application. And you put this in there, and you would tighten the bottom here. I mean, this is not going to be an exhaustive teaching on telescoping gauges, but I'm just going to give you an example. And now, by doing this over the years by feel, I can get a reading here that I would then use my micrometer to find out what the diameter of the bore is. The weakness of this method is you're only getting a measurement from one single place at any given time. and you can't really see the rest of what's going on in the cylinder, even if you'd have to take a lot of individual measurements to try to figure that out. So these work. It can give you a very accurate bore size, but you're only getting that size at one static location. You can move around to try to figure it out, but it has its limitations, and they're not nearly as accurate as a dial bore gauge. Now, what about our old-fashioned Starrett cylinder gauge? Now, the advantages to this tool is you're able to slide up and down and even rotate to be able to check for any large tapers or out of round scenarios. You can see here that I've moved it, and it's actually indicating now that there's been a change just under 1/1000th of an inch. The problem with this tool is it's just not fine enough of a tool. The graduations are only in 1/1000th of an inch, and when you're dealing with a highly accurate product like the BMW Airhead cylinder, they're not giving you much for tolerances to work with, so you need something that's a little bit finer than this. This works well on a lot of the older tractor and old school American iron applications, but on stuff that's more sensitive like modern engines and whatnot, it's harder to use. Now see, I just rotated it again, and I found that I am getting a reading. There's some variation there, but as I said, it's hard to use this as an accurate tool for our application today. And what I have here, there are different brands and types. Probably the best dial bore gauge on the market would be made by Sonnen. I have here one that is made by Mitutoyo, which is a good Japanese brand. I have a set of Starrett gauge blocks here. I've made a Starrett gauge block stack of 3 inches and 700 thousandths, because as we're looking at this cylinder, we're going to see that a B piston is 3.6996. And so I made a gauge block stack of 3.700 that I then tested my micrometer on. And so the first thing I'm going to do is I'm just going to check my micrometer and see that it's going to read accurately to the gauge block stack. And we can see that it does. So I know that I'm going to lock this micrometer, and it is set at 3 inches, 700 thousandths, which is 4/10 above the size of the BMW B piston. It's going to be important that I remember that. I've locked my micrometer, and I can set my bore gauge. I've set my micrometer here on a stand, and I'm going to use the dial bore gauge now. And I'm going to set it between the locked micrometer. And I need to balance this so that my contact points are kind of in the center of the carbide faces of the micrometer. And then if you look up to my gauge, I have this set so that as I gently rock the bore gauge, I'm coming to my 0 point on the gauge. Now I know that this bore gauge is zeroed at 3 inches, 700 thousandths exactly. We're back over to our cylinder now, and I'm going to take the probe section of my dial bore gauge, and I'm going to wipe it clean, and I'm going to put it inside the bore of the cylinder. With the dial bore gauge in the bore, looking at the face of the dial, 0 was set here. That's our 3 inches, 700 thousandths. Anything on this side of the dial, indicated by the plus sign here on the face of the gauge, is larger than 3 inches, 700 thousandths. If it was smaller and we weren't to size yet, it would be on this side, on the negative side of the bore gauge. So as I rock this, and I'm going to bring this up, I'm going to look for this to get to the lowest point after the plus side, because as I'm rocking it, I can increase what the probe thinks the bore size is, because I'm holding the contact points at an angle and it's growing. So as I get it here so that the gauge is fairly level, I'm going to rock this and find out where the indicator is reading the smallest reading on the plus side. And you can see here that I'm getting, as I rock it, around 2 thousandths and 1/10, or 21/10 oversize here in the bore. So we started with 3 inches, 700 thousandths. And we know that we had 21 tenths over, so we're going to go 0.0021, which has us at 3.7021. Now the standard size bore for a B piston is 3.6996. So we can simply do that, 3.6996, and we are 2.5 thousandths oversize of the bore. Now here's the strength of the dial bore gauge method over the telescoping gauge. When we use a telescoping gauge, we can only get one static measurement at a certain point, which right here would be about 2 thousandths oversize of the 3.700. Now I can set this dial bore gauge here, and by feel, I can go up and down the cylinder and take readings. Now see, we have tightened the bore now by 5 tenths or a 0.5 thousandths of an inch by going down in the bore. And that's typical. You're going to have more wear at the cylinder head side or the top of the cylinder compared to the bottom extreme of the cylinder. So we can see that at the very lower extreme, we have an 8 tenths taper from where we were measuring at the top of the cylinder, or near the top of the cylinder, to the bottom of the cylinder. So this gives us a much more dynamic way. We can check 90 degrees very easily. And we can see that this is also out of round by about 3 tenths. So there's issues with this cylinder. And the dial bore gauge method is allowing you to see very accurately what's taking place in your bore over using the other methods that I showed. Once we've taken all our measurements, we can come to the book and find that depending on the model, which for this application is going to be under the all other 1000cc models, and I didn't show this on the video, but I did measure the piston previously, and I found out that it was a B piston, which gives us that starting bore right there, 3.6996. And now we can find applicable clearances and other things here that would help us determine what to do with the cylinder that we're evaluating. Now, this is just a short video to give you a brief understanding of how to measure a cylinder accurately. Now, this video does not have time to go into evaluating all the data from each one of these cylinders, miking the piston, evaluating the piston, going back to the book, getting your minimum and maximum clearances that are allowed by BMW, and figuring all that out. But I just wanted to show you, for the sake of a short video, how to do this accurately. And then maybe we'll do another video in the future on, once we gather all of our data, how to look at different options for different things and see what we would recommend for a customer in this situation. Thank you for watching. I hope this was a good video for you. I hope you learned something. Make sure you leave a comment and like and share these videos. Please click that subscribe button for more content. And until next time, have a great day.